Here is another question on the same topic, work, energy, power, and this is about work and energy only because we don't have power here. It says a block of mass 5 kg is released from point A and is rides on the frictionless track. Determine the block's speed at B and C. Also determine the net work done by the gravitational force on the block as it moves from A to C. So the first part that we need to do is we need to find the speed at point what? At point B, also at point what? C. Well, so here is the thing. To find the speed at block B, here's what we need. We are going to choose the conservation of mechanical energy. We know that as the block is here, right? Due to height, there's some form of potential energy. You agree? Now, because there is height here and the ball is coming from rest, it's not moving, so the velocity is 0 and the speed here is not there. So there is no kinetic energy at point A, there's only potential energy. But as the block now is moving, remember, for this to move, that means it has got kinetic energy. That means at point B, there are all those two forms of energy, the kinetic energy and potential energy. Reason is simple. It's what is sliding, so it has got kinetic energy at this particular point. Plus, it also has got potential energy due to this height here. There's also potential energy. At C is the same situation. There's kinetic energy and potential energy. But at A, there is only potential energy, no kinetic energy, because it wasn't moving at point A. Now, knowing this, we can now break down this into their own formula. Well, for A, we are saying we are going to use the conservation of mechanical energy. So what do we say? At point A there. Remember we are saying at B and C. Now at B here we need to find the change in height. You agree? So at B we are going to have the final and the initial, of course. So we have the kinetic energy, okay, and the potential energy, okay, at B should be equal to the kinetic energy plus the potential energy at A. You agree? Right? This is what we are saying in the first place. We need to find the change in height. Now, remember what I said, that at point B, we have both kinetic energy and potential energy. That means we are having kinetic energy, mv squared, plus potential energy, mgh. All right? This is all at B. So this is velocity at B and this is the height at B. Take note. Equal to kinetic energy at A we don't have. So here is 0 for kinetic energy. We only have potential energy, which is mgh, which is at A there. Alright. Therefore, remember we are looking for the speed. So speed is already here. So we're just going to make V the subject of the formula. Remember you're looking for speed at B. That's why it has remained here. This will be equal to mgh at A minus mgh at B. Alright. Now, this is the same as mv squared B we divide by 2. You agree? Then here mg is common, so we can take it out. Mg. So we have HA minus HB. These two can multiply everything there. And remember the mass is common, right? So we can take out the mass. That mass goes 2 times this side. We have V squared at B is equal to 2G. All right. Then we're multiplying at the change in height between A and B. Remember there's a square here, of course. So whatever that we do there, we are going to square root it. So this will be the velocity at B will be equal to the square root of 2. What is G? G is 9.8. Remember, this is the value of gravity on Earth. HA is just the height at A, which is 5, minus at B is 3.20. Get your calculator and punch. After punching, because 5 minus 3.2 is actually 1.8, then 1.8 times 2 times 9.8, then you square root that number. It has given me, remember physics, you round off to 3 significant figures. So this should give you 5.94 meters per second. That is how it's supposed to be. This is energy. So conservation of mechanical energy is very important. Now, part B says the net work by the gravitational force on the block as it moves from A to B. So to C. So as it moves from A direct to C there, that means we just have to find the energy at A and the energy at C, then we subtract. That will be the net, right? All right. So part B, we are talking about the work done by the gravitational force. So it will be work done, all right, by the gravitational force. It will be equal to the what? The change in potential energy. Remember, when we talk of gravitational force, we are not talking about kinetic energy. No, we're talking about potential energy. Take that into consideration. So we have the change in potential energy. So we have the change in potential energy, all right, from A to C. That should be the simplest way we can put that statement. Now, this will be equal to, we have the potential energy, okay, at A, due to gravity, remember, by the way, all right, minus the potential energy due to gravity at point C. Now, this is just mgh, right? This is just m. You know the formula for potential energy. Potential energy is equal to mass times gravity times the distance, the height. This will be HA minus mass height C. Now, mg is common. Okay. To avoid the repetition, just take it out. Then you have HA minus HC. And the work done by gravity will be equal to the mass. Remember, the mass has been given already. And the mass was 5. So we're saying 5, you're multiplying by 9.8. The change in height is 5. It's 5 minus what? 2. Should be just be 3. This is 49 times 3. So the work done by gravity, which is the net work, is just 100 and what? 47 Newton meter, or you can say 147 joules. So this is how you're supposed to answer this question. I hope you learned something here. Don't forget to subscribe to my YouTube channel and share the videos.